Hello and welcome to this video. We're going to learn about solving simultaneous equations by matrix method. Remember, sometime back in the past we learned how to solve simultaneous equations by elimination method and also by substitution method. And if you never happened to watch those videos, you can follow the links in the description box below. And so in this video, I want us to learn another method of solving simultaneous equations, and that is by matrix method. So what we do in this method is that we're going to extract a matrix. We're going to extract a matrix of the coefficients. So we're going to write this coefficient, that is 3, 2, 1 and -1. We're going to write them here. So we're going to have 3, 2, 1 and -1, and then we're going to multiply by the variables x and y, and this should give us 12 and -1. So what we have done is that we have just represented this equation in a matrix form, and I want us now to confirm whether the way we have represented them is actually the correct way to represent these two equations. Remember also, sometime back in the past we learned about multiplication of matrices, and that is the same concept that we're going to apply for this case. And if you happened also not to watch that video, you can also check it out via the link in the description box below. So we said that for us to multiply two matrices, now these are 2 by 2 matrix, these are 2 by 1 matrix, and these are 2 by 1 matrix. Remember, we said that for us to multiply two matrices, the number of columns of this matrix must be equal to the number of rows of this other matrix, and the product that we're going to get will be a 2 by 1 matrix, that is for this case. So we also said that we multiply a row by a column. So for this case, if we multiply 3 by x and then 2 by y, we should get 12. Okay, if we multiply 1 by x, -1 by y, we should get -1. So this means that 3 multiplied by x, okay, 3 multiplied by x plus 2 multiplied by y, 2 multiplied by y should give us 12. Okay, then 1 multiplied by x, which will still remain as x, and then we add it to -1 times y, which is -y, should give us -1. Okay, so this is going to be 3x plus 2y is equal to 12, and then for this one we're going to have x minus y is equal to -1. So you see, these equations are similar to this equation. So this means that the way we have represented these equations in matrix form is actually correct. So what we then do, okay, let me write this matrix down here so that it's going to be clear. So we have 3, 2, 1, -1, and then we have x, y, then we have 12 and -1. So what we then do is that we pre-multiply this matrix by its inverse, and we multiply on both sides. Okay, so remember, we also learned about finding the inverse of a 2 by 2 matrix, and if you never happened to watch that video, you can also check it out via the link in the description box below. So let's find the inverse of this matrix. So we said for us to get the inverse, we need to first of all get the determinant, okay? And we said that to find the determinant of a 2 by 2 matrix, we need to get the product of this row, and then we subtract the product of this other row. So we're going to have 3 times -1, which is -3, and then we subtract the product of this other diagonal, that is 2 and 1, so that will be 2. So our determinant is going to be -5, okay? So to find the inverse, we now have, or we write it as 1 over the determinant, which is -5, and then we interchange the position of 3 and -1. So we're going to have -1 here and 3 there, and then we're going to have -2 and -1. Remember, we did that in a video that I did some time back, so if you have not checked out those videos, you can check them via the links that I have said in the description box below. So we have found out the determinant, or rather the inverse of this matrix. So we can open this bracket so that we have so 1 over -5 we multiply by -1, so that will be a fifth. This one will be a fifth also. This one will be 2/5, and this one will be -3/5. So that is the inverse of that matrix. So as I have said, we need to pre-multiply by the inverse of this matrix. So pre-multiplying means that we're going to have the inverse in front of this matrix. So we're going to have 1, or rather a fifth, and then 2/5, a fifth, and then -3/5. Then we're going to multiply by this matrix, that is 3, 2, 1 and -1. Then we have x and y, and then we do the same for this other side of the equation. So we're going to have 1/5, another fifth, then 2/5, then -3/5, and then we multiply by 12 and -1. Okay, so I want us to work out this. So as we said during the video about multiplication of matrices, we need to multiply a row, and a column. So for this case, we're going to have a fifth, okay, 1/5. So this 1/5, we're going to multiply it by 3, this 3, and then we add it to 2/5 by 1. So we have 2/5 multiplied by 1. Okay, then that is the first element. Then for this other one, we're going to have a fifth also, that is a fifth, we multiply by 2. So we have a fifth multiplied by 2, and then we add to 2/5 multiplied by -1. So we have 2/5 multiplied by -1, and then let me put a bracket. And then for this other one, we're going to have a fifth multiplied by 3, this 3, a fifth multiplied by 3, and then we add it to -3/5 multiplied by 1. So we have -3/5 multiplied by 1, and then finally for this last element, we're going to have a fifth multiplied by 2. So we have a fifth multiplied by 2, and then we add it to negative 3/5 multiplied by negative 1. So we have negative 3/5 multiplied by negative 1. Okay, so this is going to be, so we have 3/5 plus 2/5, that is going to be 5/5, so that will be 1. And then for this element we're going to have 2/5 plus negative 2/5, so we have 2/5 minus 2/5, that is going to be 0. And then 2/5, okay, for this one we're going to have 3/5 minus 3/5 is going to be 0. And for this last one we're going to have 2/5 plus 3/5, so that's going to be 5/5, which will be 1. Okay, so we have multiplied that matrix by its inverse, and then we have x, y, and then, okay, let me first, for this other side, let me first write it the way it is. So we have a fifth, 2/5, a fifth, negative 3/5, and then we have 12 and negative 1. So there's something that I want us to learn here. So we all know that, okay, let me not assume that we all know. Now when we multiply a matrix by its inverse, we get an identity matrix. Okay, this is an identity matrix, and an identity matrix simply means 1. Okay, so if we multiply a matrix by its inverse, we simply get 1. Okay, so this is simply 1. So 1 multiplied by x and y will simply be xy. Okay, so you don't have to work out all these multiplying a matrix by its inverse. We could simply write it as x and y, since a matrix multiplied by its inverse is going to be 1. Okay, so you just work out the right hand side. Okay, and that will save you some time. So let's multiply the right hand side of this equation. So we're going to have a fifth. Okay, let me use a different color. So a fifth we multiply by 1, and then we add it to 2/5 multiplied by, okay, oh sorry, we're going to multiply by 12. This is not 1 but 12. I'm sorry for that. So we're going to have 1/5 multiplied by 12, and then we add it to 2/5 multiplied by negative 1. So we have 2/5 multiplied by negative 1, and then for y we're going to have a fifth multiplied by 12. So we have a fifth multiplied by 12, and then we add it to negative 3/5 multiplied by negative 1. Okay, so let's work this out. So we're going to have this is going to be 12 all over 5 minus 2 all over 5, and then for this other one we're going to have 12 all over 5 plus 3 all over 5. So this is going to be 10 all over 5 and 15 all over 5. Okay, so this is equivalent to, okay, we have x and y is equivalent to 10 over 5, which is 2, and 15 over 5, which is 3. So this means that the value of x for this case is 2, and the value of y is 3. So I see we are running out of time. Let's meet in the next video, and we're going to look at more examples of the same so that we can understand in a better way. Let's meet in the next video.